In question 9 of this series, we have to integrate the function square root of x squared minus 4 dx. To do this, we'll use inverse trigonometric substitution. To use inverse trig substitution, you need to match your function with one of these three expressions. The one that matches this perfectly is this expression shown here. We have the square root of x squared minus a squared. So in that case, our a, which is our constant term here, will be the square root of 4, which is 2. And so we have x is equal to 2 times secant theta. Remember, secant is the reciprocal trig function of cosine. The next step is to take the derivative with respect to theta. And if I do that, I'll end up with dx over d theta is equal to 2 secant theta tangent theta, which happens to be the derivative of secant theta. Now I'll solve for dx so that I can replace an expression in for dx. We want our function to be exclusively in terms of theta, and then we'll revert it back to x once we're done. So we have dx is equal to this expression d theta. Now, the next thing that I want to do is visualize what secant x over 2 looks like on a right triangle. Remember that a right triangle with this configuration would be like this. We would have an angle, and secant is the reciprocal function of cosine. Cosine is adjacent over hypotenuse, so therefore secant is hypotenuse over adjacent. This means that our hypotenuse will be x, our adjacent will be 2, and this opposite will be square root of x squared minus 4. That's identical to our expression. Moving forward, what I'll do is replace this x with what I set it as, which was 2 cosine theta, and replace this dx with this. Let's go ahead and do that. We have the integral of the square root of 2 times secant theta to the power of 2, which is 4 secant squared theta, minus 4, and the rest is shown here. Following this, I'll take this 2 outside the integral and factor out a 4 here. If I factor out a 4 from these two terms, I'll end up with the square root of 4, which is 2, and I can pull that 2 out as well, giving me 4 theta secant squared minus 1 secant theta tangent theta d theta. I know I'm skipping a lot of steps here, but the reason why I'm doing this is because this is the 9th question in this series, and by now you should be able to pick up on these small tricks. The next thing that I'll do is replace secant squared theta minus 1 with its identity of tangent squared theta, and by square rooting tangent squared theta, it becomes tangent. Tangent times tangent gives us tangent squared theta secant theta d theta. Integrating this next function will be very difficult, so we have to be clever. What I'll do is go back to what tangent theta is equal to. Tangent theta is equal to secant squared theta minus 1. So I'm going to replace tangent squared theta with secant squared theta minus 1 times secant theta d theta. I'll multiply this secant theta into both of these terms, giving me 4 times the integral of secant to the power of 3 theta minus secant theta d theta. I do have a video on how to integrate secant cubed theta and secant theta. Feel free to do a search for those. So with that in mind, I won't go through the integration of these two individually. Instead, I'll just tell you what secant cubed theta and secant theta is, their integrals. The integral of secant to the power of 3 theta is 1 over 2 secant theta tangent theta plus 1 over 2 ln absolute of secant theta plus tangent theta minus this part now, and the integral of secant is ln absolute of secant theta plus tangent theta. And all of this is being multiplied to 4 plus c. Remember, we started off with a function and that was in terms of x. This expression is exclusively in terms of theta. So what we have to do is go back to this triangle that we made earlier and find out equivalent expressions for tangent theta, secant theta, and replace all thetas for expressions of x. Let's go ahead and do that. Let's start with secant theta. Secant theta we know was x over 2. So I'll replace this with x over 2. That stays the way it is. How about tangent theta? Tangent is opposite over adjacent. Our opposite is this expression over the adjacent of 2. So we have x to the power of 2 minus 4, that's square rooted, over 2, plus 1 half ln of, once again, x over 2 plus this expression minus ln x over 2 plus square root of x squared minus 4 over 2, close the bracket, plus c. This is the integral of the following function. And there you have it. That is how to integrate using inverse trigonometric substitution.